So in this video we will be looking at cases where two people are traveling in opposite directions, and we'll be looking at how their meets are happening. After what events do their meets happen? So that's what we're going to look at. So first thing, we'll look at circular track problems. In circular track, let's say two people are there. A is traveling in clockwise direction and B is traveling in anti-clockwise direction, and for the simplicity of it, let's assume both of them are traveling in equal speeds. So when will their first meeting happen? When A covers half the circumference, B will also cover half the circumference because they are traveling in equal speeds, and here is where their first meeting is going to happen. So A has covered half the circumference, B has covered half the circumference, and together they have covered one circumference, and meet number 1 has happened. Right. Now from here, A is traveling in clockwise direction, remember. So A will continue to travel in clockwise direction and B will continue to travel in anti-clockwise direction, and then they will meet here once again for their second time. So here what is happening is, from this particular point, A is covering half a track length, half the circumference, B is covering half the circumference, and together they are covering one circumference, and which is why their second meeting is happening. So this pattern will keep repeating, and it doesn't really matter how much A and B are actually covering. As long as together they are covering one circumference, one more meeting will happen. Together they are covering one circumference, one more meeting will happen, fourth meeting will happen. Let's look at a second scenario where A and B are traveling at speeds of, like, let's say A is traveling at 1 meter per second and B is traveling at, let's say, 3 meter per second. Let's see what's happening here. And let's, for the simplicity of it, let's assume that the circumference of the track is 4 meter. It doesn't have to be, but for the simplicity of it, let's assume it's 4 meters. Now A starts here and A covers 1 meters in 1 second because A is going at a speed of 1 meter per second. What happens to B? B starts here and B covers 3 meters, 1 meter, 2 meter and 3 meters. And this is where the meeting happens. Now, if you look at it, A has covered 1/4 of the circumference, B has covered 3/4 of the circumference, and still a meeting happened because together they have completed one circumference, and therefore a meeting has happened. So for circular track problems, it's very simple. Irrespective of their speeds, whether A and B are in 1:1 ratio, doesn't matter. Whether A and B are in a 1:3 ratio in terms of their speeds, it doesn't really matter. As long as together they complete one circumference, one meeting point will happen when they are traveling in opposite direction. Some of you might have guessed right now, when they are traveling in same direction, the difference of their distances should be equal to one circumference for meeting to happen. For each meeting to happen. That is not the point of this particular video, so we'll leave it at this point. The point I'm trying to convey here is, when two people are traveling in same direction in circular track problems, the faster guy should travel one circumference extra than the slower guy for one meeting point to happen in same direction scenario. Or in other words, in same direction scenario, the difference between the distance traveled by the faster guy and the slower guy should be equal to one circumference for meeting to happen. But the point of this discussion is not about same direction movements. We are focusing specifically on opposite direction movements. So in opposite direction movement, the summary that we can take is, together they should, or in other words, sum of their distances should be equal to one circumference for the first meeting to happen. Sum of the distances covered by A and B should be equal to one more circumference for a second meeting to happen, etc., etc. This is irrespective of what is their speed ratio, and which is why circular track in circular track scenario, the opposite direction scenario, it is relatively easy for us to go and identify after what distances we will have one meeting point, we'll have second meet, etc., etc. However, when we move into linear track scenarios, right, we have two variations that are coming into picture. Variation number 1 and variation number 2. The variation 1 is, what I mean by variation is, there's a different occurrence that's happening in linear track as compared to circular track. In variation 1, you will see that whatever is happening for the first meet is not the same thing that is going to happen for the subsequent meet. So that is variation number 1. And variation number 2 is, you will see that things are going to get complicated when their speeds are significantly different from each other. When the speeds are significantly different from each other, things get slightly complicated. We'll look at this. Now, let's pick up a linear track here, and let's say A is starting from one end of the track and B is starting from other end of the track. Now, once again, for simplicity's sake, let us assume that their speeds are equal. Now, what happens for until the first meeting? A covers half the track length and B covers half the track length, and therefore one meeting happens. So the first meeting is relatively easy. A has covered half the track length, B has covered half the track length. Together they have covered one track length, and therefore meeting number 1 has happened. This point is simple. Now the variation occurs from the second meeting. Now let's see what is happening after A starts from this point and moves to the other end. And if A starts from this point and moves to the other end, even if A completes half more track and B completes half more track, the second meeting doesn't happen. B has to return back and complete one more half a more track length. A has to return from this point and has to cover half a track length. So together, if you see, A has covered half plus half one track length. B has covered half plus half one track length. So only now the second meeting is happening. Or in other words, for the second meet to happen, A has to cover one track length, B has to cover one track length, and together they will have to cover two track lengths for the second meeting to happen. Now what happens in the subsequent meets? Once again, this A will have to go half, come back half, so together one track length together. And I mean, like the sum of distances traveled by A from the second meet until the third meet is one track length. And similarly, B goes half, comes back half, so B also covers one track length. So only then the third meeting is happening. So B has to cover one track length, A has to cover one track length, together two more track lengths, and only then a third meeting is happening. And this pattern will keep repeating in subsequent terms. So what we see here is only for the first meet, you can see that one track length is needed together. But for the subsequent meets, two track lengths will have to be covered by these two people together. And it doesn't really matter what is the, it doesn't really matter to a point what is the speed ratios of A and B. As long as together they complete first one track length, first meeting happens. Together, if they cover two track lengths, two more track lengths, second meeting happens. Together, if they cover two more track lengths, a third meeting happens, etc., etc., etc. So, what is the problem here? The problem here is, like, we are seeing two variations. First variation is like in circular track problems, irrespective of which number of meet, the person will have to cover that many number of circumferences. That's all. That together A and B should have to cover that many number of circumferences. If let's say A and B together complete 3 circumferences, it means they are meeting for the third time. This is very simple, but that is not the case here. In linear track, let's say if A and B are together covering, let's say 7 track lengths, right? It means they are not meeting for the 7th time, rather they would have covered one track length for the first meet to happen, 2 more track lengths for the second meet to happen, 2 more track lengths for the third meeting to happen, and 2 more track lengths for the fourth meet to happen. So together they have covered 1 plus 2 plus 2 plus 2, 7 track lengths, and only now like 4 meets are only happening. So this is the difference number 1 with respect to circular track scenarios and linear track scenario. Okay, now that this part is clear, I'll come back to the second variation later. Now let's go and look at some problems here with respect to linear track where two people A and B are traveling from opposite directions. Okay, we have this question. Two bodies A and B start from opposite ends P and Q of a straight road. So we have P city here and let's say Q city here, and A and B are traveling in opposite direction. A is going from left side to right side and B is going from right side to left side. They meet at a point 0.6 d from P. So they are meeting at a point which is 0.6 d from P. Find the point of their fourth meeting. It is given that the distance between P and Q is d. So the entire track length is d and they are meeting at 0.60. So let's see what is happening. This can be solved in a couple of methods. First we'll do a manual method to visually see what is happening, and then we'll pick up a methodological approach towards it. A normal method would be something like this. A manual method. If they are meeting at 0.60, let's split d into 5 parts. Right? 1, 2, 3, 4, 5 parts. Now let's keep color coding for A and B. Let's pick blue color for A and let's pick red color for B. So what they're saying is like the first meeting happens 0.60 from P. 0.60 is nothing but 3 by 5 times the distance, or 3/5 of the distance. So A has covered 1, 2, 3 units, and this is the first meeting that is happening. Meanwhile, B has covered 2 units. So the total distance is d. So this is 0.2d, 0.4d, 0.6d, 0.8d, entire 1d. So out of this 1d, the meeting happens at 0.6d. So this point, or in other words, A has covered 3 units and B has covered 2 units, right? For the first meeting to happen. Now let's see what's happening. Let's continue doing the same thing. Now let's, so every time A makes 3 movements, B will make 2 movements. So now let's make B move 2 units, and this time A would have made how many movements? 3 movements. 1, 2, 3. So this is the point of first meeting. We are searching for the second meeting. Now B makes 2 more movements. 1, 2, and when B makes 2 more movements, A would have made 3 movements. 1, 2, 3. So this is the point where they are meeting for the second time. Fine, fair enough. Now let's continue the same thing. Every time A makes 3 units movement, B would make 2 units movement. So let's make A move 3 times. 1, 2, 3. And meanwhile, B would cover 2 units. 1 and 2. Now every time A makes 3 movements, B makes 2. So A makes 1, 2, 3 and reaches Q. At the same time, this guy also reaches Q. So this is where third meeting is happening. Now after they meet here, let's see, both of them will return and they'll start moving to P. So every time A moves 3 units, 1, 2, 3, B would have made 2 movements, 1, 2. And every time once more, 1, 2, 3, B would have made 2 units movement. So this is where their fourth meeting is happening. So this we have done it manually. But I don't think manual approach might be a good approach because in this particular scenario they have just asked for fourth meeting, and so it's easy for us to go and do it. What if the question is slightly different, where manual approach might take even more time than what it has already taken? So we need a method, right? So let's say A, B, C. A has covered 0.6 distance and B has covered 0.4d distance. Not C, it's actually together. So together they would have covered 1 distance and meet number 1 has happened. So every time together they are covering 1 distance, these two people's speed ratio are in 3:2. Only if their speed ratio are 3:2, every time A covers 3 units, B would also cover 2 units. So now for the second meet to happen and for the third meet to happen and fourth meet to happen, this guy should cover 2d more distance, 2d more distance, 2d more distances. So if they cover d distance together, A would have covered 0.60 and B would have covered 0.4d. if they are covering 2D distance, A would have covered 1.2D, and in the meantime B would have covered 0.8D. So every time they cover 2D distance together, A would cover 1.2D and B would cover 0.8D. 1.2D more and 0.8D more. 1.2D more and 0.8D more. So what is the sum of distances traveled by A? 4.2D. And what is the sum of distances traveled by B? 0.8 into 3, 2.4, 2.8, 2.8D. And what is the sum of distances that they have traveled? 7D. And which is why their fourth meeting has happened. So A has covered 4 times the entire distance and 0.2 times more. So A would have covered 1, 2, 3, 4, and from here 0.2. So 4 entire distances plus 0.2, which is what we found here also. The fourth meeting point happens at 1/5 distance from P, or 0.2D distance from P. And meanwhile, we can also follow B's journey, and we can still get the same answer. B has traveled 2.8D for the fourth meet to happen. So B starts from here. So 1, 2, 2 times he has 2D he has traveled, and then B has covered 0.8D for the fourth meet to happen. So these are two ways of going ahead and identifying it. The second way also, the second approach that I've mentioned here also is slightly manual only. We can still optimize it further. The way we can still optimize it further is A has covered 0.60 for the first meet to happen, and whatever he is, it's not just the total distance is in the ratio of 1:2:2:2:2. It is even A's distance covered will be in the ratio of whatever he has covered in the first meet. If it is in 1 x unit, the subsequent meets, for the subsequent meets, he would have covered 2x, 2x, 2x more distances. So for the second meet, A would have covered 1.2D more, 1.2D more for the third meet, and 1.2D for the fourth meet to happen. So A would have covered a total distance of 1.2 into 3, 3.6 plus 6.6 is 4.2 distance. So 1, 2, 3, 4, and then 0.2. So we can go and clearly say that AB meeting happens for the fourth time at a distance 0.2D from left side P city, or 0.8D from right side Q city. So this is how we can go and solve this kind of question. Let's go and solve one more question. Two friends A and B start from two cities P and Q towards each other. They are moving towards each other. They meet for the first time and both of them are at a distance of 60 kilometers from P. Okay, so we have city P and we have city Q, and we have a person A. Let's give the same color coding, A, who is starting from left side to right side, and we have a person B who is starting from right side to left side, and both of them are meeting each other at a distance of 60 kilometers from P. What is the total distance? We have no idea. After the meeting, A continues towards Q and B continues towards P. On reaching Q and P respectively, these two people return back, and then they keep moving to the opposite cities. They meet for the second time when they are at a distance of 80 kilometers from Q. The ratio of speed of A and B is what? So this problem also can be solved in a couple of methods, but here we have no idea what is the total distance. We have no idea what is the total distance. The question can as well be what is the total distance here also. They are asking what is the speed ratio, but the question for this particular problem could also be what is the total track length. What is the total track length between P and Q? How do we approach here? This is what is happening until the first meet. So what is the distance covered by A? 60 kilometers. What is the distance covered by B? We don't know. Let's assume the total distance is D, so this must be D minus 60 kilometers. Okay. Now what is happening after the first meet until the second meet? A goes to the opposite end and comes back somewhere here. We don't know where, but somewhere. And whether this point is in this side of the track or in this side of the track, we have no idea. Until we know their speed ratio, we have no idea. So let's assume that somewhere around this point they are meeting, and B goes to this P city and comes back and meets here. Now the data point that they're giving is when they are meeting for the second time, they're at a distance of 80 kilometers from Q. So this distance is 80 kilometers is what they are saying. This distance is 80 kilometers. This distance, not this entire distance, rather just this left side distance. I mean just this distance is 80 kilometers. Now this problem, there are a couple of ways to solve it. One way of solving this would be, A has covered how many kilometers for their first meet? 60 kilometers, right? Now tell me how many more kilometers would have A covered for the second meet? For the first meet, if A is covering X unit, for the second meet, A would have covered 2x extra. So which means, let's look at the previous example. For the first meet, if A is covered 0.60, from the first meet until the second meet 1.2 distance, from the second meet until third meet 1.2 more distance, etc, right? Similarly here also, for the first meet, if A is covered 60 kilometers, and for the second meet to happen, A would have covered 120 kilometers. It would be 120 kilometers, right? So A has covered 120 kilometers, but we know one information, this distance is 80 kilometers. So what it means is, this must be 40, only then 40 plus 80 should be equal to 180. So we can go ahead and say that the track length is, this must be 40 kilometers, and because we know that from the first meeting until the second meeting, the total distance traveled by A is 120. We know here A has traveled 80. So here A must have traveled to 40. So we can go ahead and clearly say that from left side it is 60 kilometers and from right side it is 40 kilometers, which means A has traveled 60 kilometers. In the meantime, B has traveled 40 kilometers. So we can go ahead and answer both the questions. What is the speed ratio of A and B? Speed ratio of A and B is 3:2 because both of them are starting at the same time and they are meeting at a point where A has covered 3 units and B has covered 2 units. Their the speed ratio are in 3, their speeds are in 3:2 ratio. Now total track length also we know, from here to here it is 60 kilometers and from here to here it is 40 kilometers. The total track length is 100 kilometers. Fine. This is method 1 of solving this problem. Method 2 of solving this problem would be, okay, there are a few more methods. We'll go one by one. What is the distance traveled by B until the first meet? Until the first meet, B has traveled D minus 60. Right. Now, from the point of first meet, from the first meet to the second meet, B would have covered 2 into D minus 60. From the first meet until the second meet, this is what B would have traveled. Right? Now what we know, let's cut it into two parts. If you look at just B has covered here 60 kilometers. And while returning, the total distance is D and 80 kilometers are here. So it must be D minus 80, what B has covered. So 60 plus D minus 80 is what B has covered from the first meet until the second meet. So 60 plus D minus 80, this is same as 2D, this distance, 2D minus 120. So cancel it out. What we have is D is equal to 120 plus 60 minus 80, which is equal to 100 kilometers. Once we have the total distance 100 kilometers, we know that A has covered 60 and remaining 40 has covered by B. So their speed ratios are 3:2. Here, this B's ratio, no, it is slightly more difficult because there are variables coming into picture. D minus 60, 2 times D minus 60 in one approach, in other approach 60 plus D minus 80. So it might be slightly difficult to comprehend. So which is why this would be the recommended approach. There's a third method in which we can go and solve this problem also. This is method 2, right? Following B. Method 1 is following A. There is a third method where, let's say, I have no idea that for the first meet, if they're traveling one circumference, one track length, for the second meet, they would have traveled 2 more track lengths, etc. That concept I don't know. Now, how do I still go and solve this particular problem? we can go ahead and follow the speed ratios, and we can still solve it. So the question is this: A has covered 60 kilometers, B has covered D minus 60 for the first meet to happen, and after that A completes the track length and comes, let's say, 80 kilometers more. That is, A completes D minus 60 and comes 80 kilometers, whereas B completes 80 kilometers more and comes back D minus 80. Now the speed ratio is always same, right? So for their first meet, what is the distance traveled until their first meet? What is the distance traveled by A and distance traveled by B? A has covered 60 and B has covered D minus 60, right? Okay. Now from the first meet until the second meet, what is the distance traveled by A? A has covered D minus 60 plus 80, which is D minus 60 plus 80 is D plus 20. Now what is the distance traveled by B from the first meet until the second meet? The distance covered is like, okay, this is like D, right? Why did I write it as, this is 60, not 80, right? So the B has covered 60 plus D minus 80. So B has covered 60 plus D minus 80. So it is D minus 20. Now in the same time frame, A has covered 60, B has covered D minus 60. In the same time frame, A has covered D plus 20, B has covered D minus 20. So the ratio should be same. So 60 by D minus 60 is equal to D plus 20 by D minus 20. So if I cross multiply, 60D minus 1200 equals D squared minus 40D minus 1200. Thankfully 1200 gets cancelled. D squared equals to 100D. So either D is equal to 0 or D equals to 100. This is not possible. Therefore distance is equal to 100. The moment we find distance equal to 100, we can go ahead and say that if this is 60, 100 minus 60, this is 40. So the speed ratio are 3:2. I think out of these three methods, I've presented with all three methods because different students might have different preferences. Maybe the first method might be simpler, but this third method doesn't need any conceptual understanding to be able to solve. Just the speed ratios, you can go and, even if you don't know the concept prior hand, you can still go and solve this problem using third method. Okay, now that we have solved a couple of problems around this concept, let's get back to that variation 2 that I was speaking about. There is some variation, there is some complication, I might even say. Let's say their A and B speeds are significantly varying. Let's say they are not 1:1 ratio. Let's say one guy is like their speeds ratio of, let's say, 3:1. One guy is like 3 times faster, 3 times the speed of the other guy. Now let's look at the track length and let's split it into 4 parts. And the blue guy travels, the faster blue guy travels 3 units for the first meeting, and the slower red guy travels 1 unit for the first meeting. So this is where the first meeting happens. Now every time blue guy travels 3 units, the red guy would travel 1 unit. So let's make the blue guy travel 3 units, 1, 2, 3, and let's make the blue guy travel 1 more 3 units, 1, 2, 3. So meanwhile the red guy would have traveled just 2 units. See, because like here the blue guy has traveled 6 units. Every time blue guy travels 3 units, red guy would travel 1 unit. Here blue guy is traveling 6 units, so the red guy would have traveled 2 units. And we might wrongly think that this is where the second meeting happens, but that is not the case. This is not where the second meeting is happened. There's a small complication happening here. When we are looking at opposite direction meeting, yes, this is the second meeting that is happening when these two people are traveling in opposite direction. Let's quickly rewind and see what is happening after their first meeting. After the first meeting, let's make this red guy travel 1 unit And let's see what is happening if B is the red guy traveling 1 unit. Now let's see what is happening if the blue guy is traveling 3 units. 1 unit, 2 unit, 3 unit. Can you see that these two people are actually meeting here? This is where the second meeting is happening even before what we expected happens. We had expected red guy to travel 1 more and blue guy to travel 1, 2 and 3 more. We expected this is where the second meeting to happen. Actually this is third meeting. Why is this unnecessary meeting happening in between? Because these guys are one guy is significantly faster than the other guy. Even before the other guy could come and take a return track, right? Return along the other end of the track, the faster guy goes and meets him. It's more like the slower guy is just coming very, very slow, but the faster guy goes meet him for the first time, comes overtakes him here and then goes back. So that's what will happen when the faster guy is significantly faster than the slower guy. So this is one complication that is there in linear track problems. In circular track problems, nothing like this happens. Because in circular track problems, when both of them are traveling in opposite direction, they'll always continue to travel in opposite direction. But in circular track problems, when one person's speed is significantly higher than the other guy, such same direction meetings will happen. So this is one small complication that might happen. So I just want to present a word of caution. Make sure that such same direction meetings are not happening. How do we ensure that? Maybe one round of slight trial and error method if their speeds are significantly apart from each other. If the speeds are not significantly apart from each other, even 3:2 is not significantly apart from each other. 3:2 is like one is 60 and the other guy is like 40, or to an extent is comparable. But this one is one guy is 75, another guy is 25, is like this is 3 times. 3 times is much bigger. Here it is just 1.5 times. This one small scope of error is there, so students should make sure that they don't fall into this particular trap. With this, we'll wind up this particular